All right, let's do this. All right. This is I'm not going to say Sam, although I was just about to. Is Sean here and we can get going? All right, so this has actually been a while since I did this test, although I have been using the fruits of it more recently. So it may take a while to kind of get my bearings, but I think may be useful to talk through it as well as I refigure some of this stuff out. So yeah, so what you're seeing is a little text executable, which, as you can see, it's plain C code. Although some, I mean, you can do C++ code as well. Although there's some limitations on that. Maybe we'll get into along the way. But certainly for mostly plain C code, this should just work out of the box. But anyway, so you can see that I'm using a bunch of CRT features. Like I have printf, which is obviously a heavy hitter. I have A to F, another heavy hitter. Copy memory, maybe not a heavy hitter. When it's not compiled to an intrinsic, it's calling memcopy in the CRT, but something that you're going to be using all the time. Even doing assignments of big structs is going to implicitly call memcopy. You can see I'm doing some stuff here that's a little more borderline. I'll get into this as this is related to auto vectorization, calling some weird specialized vector versions of cosine and other math functions. That's actually something that's not in the thing I'll be showing, but anyway. All right. Boom, boom, boom. Yeah, so you can see there's all this stuff. There's also SEH support, which is very important. So, let's compile it and run it to show you guys. Um, let's see here. So you can see it's calling this, and this should all work. It's calling cosine, which is also from the CRT. It's not vectorizing in this case. I guess I must have turned it off, but I remember testing it earlier. So anyway, yeah, this is all like good stuff. If you go look at like there's anyway, so this just works, and let's look at how big this thing is. 1 second. So yeah, the thing this generates, this is the x64 release version. If you look at the executable, it's 4K, actually 3.5. So if you guys have done Windows programming, you know a 3.5K executable that has all these CRT features is a little bit of a feat. And I didn't really have to do anything crazy to accomplish it. So I'll be talking about basically how you get that. How can you have all these nice features with no dependency on, the Microsoft, like I'm using Visual Studio 2015. Normally, if you link against the standard compiler provided CRT, you have to, you either have to assume that your end user has the redistributables for that compiler version installed, but actually, if you're distributing an application and not being a dick and actually providing what your user needs, you need to co-distribute basically that redistributable installer. If you guys install games, you probably notice this a lot, right? Like it will install during like the Steam install or whatever. It will sometimes install the a redistributable for whatever compiler version was used to compile the game. So we don't have any of those dependencies. And so how do we do that? It seems like magic. So that's what I'm going to talk about. The backstory of this, and I can't remember where I first learned of it. Let me open a incognito browser so we can do some Google searching. maybe I can rediscover things about this, just Googling it. Maybe not. But anyway, the reason this works is, just bring up the prompt here. The reason this works, actually, let me bring up the command. Native tools. Let's bring up the Visual Studio command prompt. Oh, let me bring up one more thing. Dependency walker. That's actually what I was looking for. Depends. Okay, so I got my trusty dependency walker here. I just want to show you guys what this thing depends on DLL-wise. So if you go to... by the way, this stream is going to be super all over the place because I didn't really think about what we would do. But if I open this thing... Okay, it seems there's an error. I don't think... Not sure why this says that, but anyway, it works, so it should be fine. You should note that it links against msvcrt.dll, and it's msvcrt.dll in Windows sys 32. So if you go there, you can see it's right here. Are you guys not hearing anything? That would be terrifying. Let me just, before I cover more stuff, let me make sure people can actually see this shit. Alright. Hey Sean, you're not seeing this? I'll just wait for Sean to catch up, since this is sort of a special Sean stream. And we'll just have a drink while waiting for him to catch up. Alright, you can see everything? I'll just rehash a little bit, although you can get more of the details if you go back. I didn't actually do anything yet. I was just sort of showing what I had. So to quickly rehash, I have a x64 executable that is 3.5 kilobytes. That is without using crazy demo scene tricks. It's literally just... Oh, and I guess the notable thing is it's not statically linking muscle, you know, like special standard library functions to replace the built-in ones. It's using the standard CRT stuff, at least the C parts. It has printf, ADF, and all this other stuff. Memcopy. It has SEH support. It has basically the works. And as I was showing, using dependency walker, it gets this from Windows System 32 msvcrt DLL, and I just got to basically showing what that is. So we will go. Boom, boom, boom. All right. Yeah. So msvcrt. You can see this is the thing here. Normally, this is what people think of as the CRT, but actually this file is not the CRT that most programs in this day and age link against. Those instead are all these guys. So you can see all of these have a version number at the end. So like, for example, the 1401 is the one for Visual Studio 2015, and this would be 2013 for 120, and so on. So I think starting with Visual Studio 2000 and is it .NET? Like, I think around 10 years ago they started doing this thing where the CRT is coupled to the compiler, right? But, and this is really nice, distributed with Windows, and apparently this goes back all the way to Windows 95, so it's not something you have to worry about, oh, this only started recently. Systems apps, like, actually they might be fun to look at Notepad, because I believe that's an example of something. The system applications like Notepad and all these others, actually use the same, and apparently also a lot of other junk. Let's see. Yeah, so you can see that Notepad uses the same thing. And in fact, a lot of I think almost all the built-in Windows tools use it because the built-in Windows tools don't assume that there's any particular compiler redistributable installed. But guess what? They still need to do basic C stuff. They're not each of them re-implementing the CRT, right? So if you think about it, something like this has to exist, right? Like, there's no way that they're re-implementing printf in a static library or something like that for all these systems apps because I mean, why would they, right? So there's this thing has always been there, basically. Sort of, people just didn't. Maybe most people didn't realize it. The question is how you link against this. So you can do load library directly, right? Like just using dynamic symbol loading and calling through function pointers. But that's really intrusive. If you're just getting printf maybe or something like that, maybe that would be okay. But it's kind of not great. So instead what I did, and I didn't make this up, I mean, I got the idea from, I guess, whoever told me about this originally, is I created my own import library in order to do this. And so the way you do that, the easy way to do that, is you create a .def file, and a .def file basically has a directive line, which is like exports, and then it has a bunch of, it just has a symbol per line that it wants to generate an import for in that library. And then, and this is the part that I have totally forgotten, let me Google it. Is it, no, dump in, so, okay, I guess let me do things in order. So I have a copy of the msvcrt.dll, just copied from system32 into this directory. If I do dump in -exports, I believe it is, on the DLL, you get this list here. Now this list is not actually the def format, and this is really hilarious, but as far as I know, there are no of the standard tools that out of the box will generate a .def file just from a plain DLL. So essentially what I did is I wrote a Python, no, I didn't write a Python script, I wrote a sed script, and I guess I have to recreate it because I don't think I saved it on disk. I wrote a sed script, and I guess, or awk script, awk print, can I do dump in from here? Can I do sed from here? Fuck me. Okay, so I guess what we do is we'll do this and then do msvcrt or something like that, and then we will do awk print. Is it 4? 1, 2, 3, 4. msvcrt exp. Okay, I don't even remember the format of awk. Okay. msvcrt exp. Okay, that was definitely not the right thing. I guess it's 0. That is not the right thing either. Okay, is this even the fucking thing I'm trying to... Okay, no, it's not. It's because I misspelled exports like an idiot. So let's try again. Okay, that's better. I think this actually misses out on a few symbols. So originally I did a little more. Like I remember the column format of this exp file is actually not perfect from what I remember. Let's check it out. Oh, that was the exp. Where is this one? If you scroll through, I believe there's some holes in the columns so that my awk script misses out. No, actually looks good. So yeah, oh yeah, this one. You can see there's some things like this one that has a hole, and I think I just filled those in manually. Let's see if there's any other holes I missed. Maybe I did actually write a Python script. Let me check. No, I did not. So anyway, but I mean, I'm sure Sean knows how to write a simple text thing. So basically, what I do, my process for generating this fucking thing, is I do the dump bin exports. I cat it to an exp file. I then basically just extract the fourth column, taking special care with the C-specific handler export. From that, I generate the def file, which looks like this. So you can see this one does have the C-specific handler. And then from that, I do boom, 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 boom. Let's see if I remember what that thing is called. Whatever the thing is called that you use to generate msvc generate import library. Okay, this is for people who don't know how to use command line. Lib, okay. So then, yeah, you use this. So let me just do a test, I guess. /def msvcrt.dll out, and let me just call it something else so we don't clobber it in case we made a mistake. Machine x64. No, because this is not the right window. libdef msvcrt. Okay, so now we have this new .lib, and you can see they're identical, so that means I didn't fuck up. And so at this point, all you have to do is link against it explicitly. I guess if I wanted to really demonstrate sort of what this does, I should start with a vanilla executable and point out all the settings you have to set up. But I'm too lazy to do that, so I'll just go through the settings here manually. So when you go to input, you have to say ignore all default libraries, and this is the /no default lib. And then you have to add things manually. You can see I add this thing here. This is the .lib that I generated myself, and just adding that, I get all the imports for that library. And then kernel 32. What is the there's another so right now normally I use the pragma comment lib to do imports actually, and obviously you don't get kernel 32.lib by default anymore when you have this setting. So you can either add it here or you can add it here, but I believe you then have to do something like additional dependencies in order to pick those up in the linker. But anyway, so I do it this way, and then you also have to go through and do a few other things, I believe, like I disable as a GS, some of the special sort of anti-buffer overflow things I disable. I don't believe those are in the CRT. And anyway, so that's sort of the basic thing. It's not too hard. Really, the only fancy step is generating the import lib. I do want to talk about a few other things, if I can remember them. One thing you'll note is that doing it this way, you only get the DLL exports from the CRT. Any of the statically linked things that you normally get from linking to the compiler CRT, you don't get. So there are some things you have to add manually. Now, if I wasn't lazy, I would create a sort of an aggregate lib that's a static library containing both those things and the imports that I generated. So maybe I should do that, but I won't do that on stream right now. But you can do that yourself. The two things that you absolutely need is like you need this one, I believe. That's one of them. The other one, I guess is not in this example, but I remember doing it, so I don't know why it's not. Let me search for checkstack.asm because I know I wrote this thing by hand. So, and actually, let's check something here. If I do big buffer, and this is like a meg, or I guess this is maybe a little too much. Let's say something like this. If I do this, it should complain about not having, or maybe it does have it from some unknown source. So, okay, so this isn't actually, I guess because I'm not referencing the buffer. So let's say I do something like this. Okay, why is it not doing a stack poke? I guess because it's doing, let's just do some stuff. I think the dead code elimination is probably being a little bit too fancy, and this is probably also too fancy. So maybe we'll do something where it can't predict the value and it has to generate code. Okay, here we go. We got the check stack missing thing. So a little bit of background. If you guys have never looked at check stack, This is something that's generated because of the way that the compiler on Windows generally grows its stack, right? So I think the default stack size on Windows is 1 meg for the main thread, and it does that by making a 1 meg reservation, but initially it only commits maybe even one page, but some number of pages, and then it has a guard page that sort of guards the frontier. And then when you access the guard page the first time, it page faults, increases the commit, adds a new page, a new guard page on top of that, so that it can kind of incrementally commit based on actual usage rather than pre-committing the whole range. That's great, right? That's a nice trick. Um, but in order to do that and without getting spurious crashes, anytime you do a stack allocation, either statically like I'm doing here, or with alloc A, it has to basically do reads at 4K stride, 4K being the page size, in order to force fault those in. And that's all the check stack does. So let's... Did I fucking delete this thing? I mean, it's not hard to recreate it, but I could have sworn I wrote that. Maybe it's elsewhere. Oh, it's here. I see. Um, Maybe I'll open up this program. This is like my old new project that I showed on stream, which also uses the msvcrt, and I guess it's more interesting maybe because it's not like a minimal test app. Um, Let me go see what people are saying in the chat, if anything. So Sean's asking, you don't need pragma function memset and the others. The pragma function memset, no, you don't need it because all of that stuff, like it's the real CRT, right? Like it is the real CRT as far as it's concerned. So you don't have to do any of those sort of stupid stunts. So anyway, this thing uses, this is a Mu test app, and you guys remember Mu. I did some work on it off stream after I wrote that originally, but anyway, so this uses that, and I I think currently it's using checkstack. So checkstack is just something. Well, I would say I wrote it, but really what I did is I copied. I basically stepped into the assembly code from the normal CRT and just transliterated the assembly code from the disassembly into my own thing. Um, and it does exactly what I told you, which is it takes steps of page size. And although this is a typo, isn't it? That's hilarious. So I apparently had a typo, which is not great. But so this does that, and I just basically, I did it in MASM, and then that's it. Now here I'm kind of manually linking it in, assembling and linking it in per app. But like I said, if you're doing a more sort of drop-in version of what I'm doing here, you would have the importer lib statically link against the extra things you need, notably the check stack, and also I guess the float used. Maybe float used is actually, I guess float used is actually in that CRT, so we don't need that. Oh, it's probably here, right? Yeah, it's here. So you would put this one and stuff like the check stack. You would put that into your import lib plus a couple of these extra things. But that's pretty much it, I believe, for these extra static things you absolutely need in order to have sort of like a normal C program that do stuff. The one thing I ran into that someone on Twitter pointed out to me is that a case that where there's a bunch of these statically linked things you need that are, or actually not statically linked, DLL linked things you need that aren't in the msvcrt.dll in System 32 is when you're doing, and I think that's what I was trying to provoke in this test, when, and let's see what's going on and why it's not doing it. Maybe I disabled auto vectorization, and maybe we can re-enable it to show what I'm talking about. Let's see here. Enhanced instruction set. I guess we will do SSE. Maybe that will trigger it. Okay. No, that's something else. That's because of that buffer. Let's try again. Big buffer. Okay, it's just ignoring it because it's x64. What if I turn on AVX? I guess this is something else to... Oh. Okay, so I guess that maybe I turned off another optimization setting to have that happen. Maximize speed, boom, boom, boom. Okay, but anyway, modern MSVC versions have auto vectorization, which means that it can take a loop like this and essentially unroll it by 4, but do those iterations unrolled by 4 with SSE. And so in a case like this, what you're going to see is that rather than calling cosine, which is obviously a scalar function, right? It operates on one float and returns one float. It will call something called like, let's see, auto vectorization. I see. Okay, so this is where someone told. This is where I posted about it originally, and this guy here, who I think is one of Casey's guys, or Casey Handmade Hero guys. Right. So basically, this one, which you can find very little on. Okay, I'm one of the hits. But anyway, this thing gets generated for the code I'm writing here if auto vectorization is enabled. And there's a bunch of them. There's a bunch of these vdecl functions, which are like vectorized versions of a bunch of math functions. And so there's like a lot of them. I would suspect that if you really care about auto vectorization, which I personally don't, like that, I'm just not. I don't really care about that stuff. But if you care about auto vectorization, I guess you could go and slurp these out of the standard, the static library part of the MSVCRT, of the compiler specific MSVCRT. Put these into your kind of addendum static library that adds on top of the import library we created. But other than that, if you don't care about auto vectorization, I don't think there's anything really major missing. This actually will give you the full sort of standard library experience with structured exception handling, stack checks for large stack allocations, all that good stuff, in a way that doesn't require you to jump through hoops. So this should work even for large programs. I don't think there's any huge limitations, but I mean, I haven't really used it for large programs, so maybe you run into stuff. But for me, it's been fine for medium-sized programs, let's say. And like I said, to go back to the file sizes, actually, let's look at this mu executable. This mu executable links against like it has a bunch of dynamic libraries it links against. It has, like, I guess let's go check it out. Has all the import libraries for. Okay, I guess I have additional assemblies here, so I can actually, when you use additional assemblies, you can just use pragma comment. I think, right? Comment. Oh. Right. So there's D2D, which is a monster library. I guess there's a bunch of other things. Don't know why those are not mentioned explicitly. But anyway, it links against a bunch of things and has not a lot of code, but like 500 lines of my own code plus a bunch of test code. And the executable, in this case, is 12K. And that's mostly because it uses a lot of Win32 code. Like I said, or like I showed with no crt.exe, with just a dummy executable that calls a bunch of standard C library functions like printf, you can easily get 3.5K executable size. So anyway, I think that's all I wanted to show. Hopefully that was useful. I guess I'll hang around for a sec if anyone has questions. Okay, I'm going to, well, I guess there's a stream delay. I'll give one more minute and then I'll take off. This wasn't intended to be super comprehensive. Hopefully this was, I think the parts that are a little bit tedious if you don't know about them is, you know, the string processing to first generate the .exp and then converting that to a .def and then creating an import lib, and everything else is sort of standard stuff. All right, for you guys who just got here, I guess. So Sean's asking, I wonder if this CTF stuff is slower than the new DLLs. I don't think so. Keep in mind that this is used by all the built-in Windows software. None of the stuff that ships with Windows uses a compiler-specific redistributable. They all use this stuff. So it's not some sort of, like, I know I said it's been there since Windows 95, but that doesn't mean that the code hasn't been updated or whatever. I'm just saying that you can depend on it being there and having the standard entry points you're used to going back to Windows 95. It's not some sort of shitty GIMP version that is only useful for, I don't know, like old old accounting programs that still have to run or whatever that happen to link against it. Like even the modern Windows programs like Notepad link against it. All right, so that's it. Hey Casey. I will shut down the stream now. If you guys want to chat, we can chat on Twitter or in the Twitch chat. So that's it. Hope that was useful.